Hello and welcome. In this video, we will solve some problems on inverse trigonometric function formulas. Here we have to find sine of sine of sine inverse of 3 by 5 plus tan inverse of 4 by 3. So we can convert this to cot inverse. So I can combine cot inverse and tan inverse, or I can convert this to cos inverse, and then I can combine sine inverse with cos inverse. So either way it works. So let me convert tan inverse into cos. So here tan inverse, if I write the triangle, tan is opposite by adjacent, so opposite will become 4, adjacent becomes 3. So if you apply Pythagoras theorem, the hypotenuse becomes 5. So what I can write is sine inverse of 3 by 5 plus, for this, what is cos? Cos is adjacent by hypotenuse, so I can write cos inverse of 3 by 5. So this is sine inverse of x plus cos inverse of x is pi by 2. So this is pi by 2. So sine pi by 2 is 1. So option B. Now let us solve this. We have secant square of cot inverse of half plus cosecant square tan inverse of half. So there are two ways to solve this. So what I do is I take this as secant of cot inverse half whole square plus cosecant of tan inverse of half whole square. Now I convert this cot inverse to secant inverse, so that I can cancel secant and secant inverse. So if I write triangle for this, what I do is I write triangle for this in red. So cot inverse of half. Cot is adjacent by adjacent by opposite. So adjacent becomes 1. Opposite becomes 2. The hypotenuse will be square root of 1 plus 2 square, which is square root of 5. So root 5. So this is secant inverse of secant is hypotenuse by adjacent 1. This is whole square. So I can cancel secant and secant inverse. So I'll get root 5 by 1 whole square. Root 5 whole square, which is 5 plus 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 and plus. Now I'll take this triangle here. Tan inverse of half. tan is tan is opposite is 1, adjacent is 2. Then hypotenuse will be again root 1 square plus 2 square, which is square root of 5. So cosecant of, let cosecant inverse, I have to write cosecant inverse to cancel cosecant and cosecant inverse. Cosecant inverse is hypotenuse root 5 divided by opposite side is 1. So this is square. Cosecant and cosecant will cancel. I'll get root 5 square again. So this is 5. So answer is 5 plus 5, 10. This is my option. There is one more method to do this. What I can do here is secant square x is 1 plus tan square x. Secant square x is 1 plus tan square x, and cosecant square x is 1 plus cot square x. So I'll use the same thing here. So this becomes 1 plus tan square of cot inverse of half plus 1 plus cot square of tan inverse of half. So 1 plus 1, I'll make it 2. 2 plus this I'll do as tan of tan of cot inverse of half whole square plus cot of tan inverse of half whole square. This is 2. Now we know that tan inverse of a by b I can write as cot inverse of b by a. Similarly, cot inverse of a by b I can write as tan inverse of b by a. So here what I do is 2 plus tan of, so in order to cancel these two I have to write this as this in terms of tan inverse. I can write tan inverse. When I write cot inverse into cot inverse to tan inverse, this becomes reciprocal, so it is 2 whole square plus cot, and I'll convert this tan inverse as cot inverse of 2 whole square. So now I can cancel tan inverse and tan, cot and cot inverse. So 2 plus 2 square plus 2 square, it's 2 plus 4 plus 4, which is 10. And here again this problem can be solved in two ways. So first way is I'll write sine of 2 tan inverse of, I'll write 0.75 as 3 by 4. So this is sine of 2x. Sine 2x is 2 sine x cos x. 2 sine x cos x. So I can write this as 2 times sine of x. X is tan inverse of 3 by 4. Tan inverse of 3 by 4 into cos of tan inverse of 3 by 4. So now with the help of this I'll write a triangle. Alright, tan inverse is opposite by adjacent, so opposite becomes 3, adjacent becomes 4, hypotenuse will be 5 if you apply Pythagoras theorem. So what I do is I'll write, to cancel these two I have to write this in terms of sine inverse. So I'll write sine of sine inverse of opposite is 3, sine is opposite by hypotenuse, so 3 by 5 into cos of, I'll write tan inverse in terms of cos inverse in order to cancel these two. So cos inverse of adjacent is 4, hypotenuse is 5. So I can cancel sine and sine inverse, cos and cos inverse. So I left out with 2 into 3 by 5 into 4 by 5. So 2 into 3 is 6, 6 into 4 is 24, 24 divided by 5 into 5 is 25. This is one method. The other method is you can directly use a formula where we have sine of 2 tan inverse of 3 by 4. So we know that 2 tan inverse of x is equal to, or we have derived it sine inverse of 1 minus, or sine inverse of 1 2x by sine inverse of 2x divided by 1 plus x square is 2 tan inverse of x. So if I take this 2 tan inverse of x, I can write this in terms of sine so that I can cancel sine and sine inverse. So I write sine into, so in place of 2 tan inverse of x, I can place this, which is sine inverse of 2x divided by 1 plus x square. Sine and sine inverse can cancel. So here x is this value, which is 3 by 4. So the value of this function is 2 into x is 3 by 4 divided by 1 plus 3 by 4 whole square. So which is 6 by 4 divided by 1 plus 9 by 16. 1 plus 9 by 16. 6 by 4 I can write 2 3 2 2. 3 by 2 divided by 16 plus 9 divided by 16. 2 1 2 8. So 8 will go and multiply with 3, which is 24, divided by 16 plus 9 is 25. So it is 24 by 25, option B. The same problem we can do in we can do it in two ways. You can apply 2 sin theta cos theta formula. What I do is I write sine 2 times cos inverse of 0.8. I can write as 8 by 10, or 2 4s are 2 5, 4 by 5. So it is 4 by 5. So this sine 2 theta is 2 sin theta cos theta. 2 sine cos inverse of 4 by 5 into cos inverse of 4 by 5. So we can write the triangle. We have cos inverse. Cos is adjacent 4, hypotenuse 5. This becomes 3, Pythagorean triplet. So this I write 2 into sine of cos inverse in terms of sine inverse. Sine inverse of opposite is 3, 3 by 5. This is cos into cos inverse of 4 by 5. I can cancel sine and sine inverse, cos and cos inverse. I'm left out with 2 into 3 by 5 into 4 by 5, which is 6 4s are 24 divided by 25. So this is one method. The other method is you can use formula. Sine of 2 cos inverse of 4 by 5. So which is sine of 2 cos inverse of x is sine inverse of 2x square root of 1 minus x square. I can cancel this sine inverse. I can cancel sine and sine inverse. So it is 2x into square root of 1 minus x square, where x is 4 by 5. Where x is 4 by 5. By substitute, we get 2 into 4 by 5 into square root of 1 minus 4 by 5 whole square, which is 8 by 5 into square root of 1 minus 16 by 25, which is 8 by 5 into square root of 25 minus 16 divided by 25 under root. So this is 8 by 5 into square root of 9 by 5, 9 by 25. So which is 8 by 5 into 3 by 5, which is 24 by 25. So option is B. Thanks for watching.